Okay, another thing you're going to be asked to do within this lesson is to just evaluate algebraic expressions. And the reason it falls under the order of operations heading is because you have to know, what order you do things in, all right? So we're going to look at a few different problems and just practice substituting values in and then evaluating them once we've done that. So let's just get started. We have a squared times 3b plus 5 divided by c if a equals 2, b equals c, and c equals 4. So all you're doing with this is we're going to find all the a's, okay, and we're going to put in 2. I'm going to use black for everything. We're going to put in 2 for that, right? And you'll find your b's, and you'll put in your 6 for that, and you'll find your c's, and you'll put in your 4 for that. Actually, I think for this first one, I will use some different colors. So let's use red for our a's. All right, so I've got an a here, so I've got 2 squared, and there's no other a's, so we're going to leave it like that. We're going to go back to black. We're going to stick with black for b. So we're going to do 3 times 6 plus 5, and you can have a parentheses inside a parentheses. It's a little harder to look at, but it's okay. You can do it. And then divided by c, and c is 4, so let's change up colors. Let's use this Dayglow green. Divided by 4. All right, so you can see kind of what's going where, right? And then at that point, it's just apply what you know about order of operations. Okay, so I know that I got to do what's inside the grouping symbols first. And once you're in the grouping symbols, you just follow the order of operations within that. So the 6 is inside its own grouping symbol, but it's basically it's already simplified, so you can kind of drop it and recognize that it is a multiplication problem with 3. So you wind up with 18 plus 5 within this grouping symbol, and then that becomes 23. Okay, next, let's deal with that 2/3, all right? So we got to do now that we've gotten rid of our grouping symbols, we're going to just, work left to right. I'm just going to write everything in red now. We're going to work left to right. Or no, we're not going to work left to right. First, we're going to do PEMDAS still, right? But we don't have to do anything with the p anymore. So we can do exponents. 2 to the third is and it shouldn't be 2 to the third. It should be 2 squared. My bad. 2 squared is 4. So now we have 4 times 23 divided by 4. So you've got a multiplication problem here, and you've got a division problem here. Well, those both kind of, fall under the next operation we have left. So just do those left to right. So 4 times 23 is 92. And then we're going to divide 92 by 4. Well, I know 100 divided by 4 is 25. And 92 is 8 less than 100, which is 2 multiples of 4. So we're going to get 23. All right. Let's look at another problem. All right, so we got a whole bunch here. So we're going to just pick a couple. I think I looked at this earlier, and I thought we would do this one and this one. So let's do 34, all right? So we have t squared. T is 11, so I'm going to go 11 squared. I'm going to write it like that, plus 8 times r, which is 3, and then t, which is 11 again, and then plus r squared, which is 3 squared. I just have a thing about writing things that are being raised to exponents in parentheses. You don't have to do it if you don't want to. It doesn't really change anything, but for me, it's just a cleaner way of looking at it. So 11 squared is 121 plus, and then I'm going to just leave this how it is, and then let's do this. 3 squared is 9. All right, now let's deal with this. All right, so we got 121 plus, well, it's 24 times 11, and so I know 24 times 10 is 240. If you do one more 24, that's 264. So you get 264 plus 9, and then you have 121 plus 264, which is 385, plus 9, which is 394, if I did all my math right. Okay, let's try 35. All right, so 3 times g is 2, all right, times, and then G is 2 plus R, which is 3, and then that whole thing is squared, and then minus 1. So we got to do what's inside the parentheses. So there's really nothing to do in this one right here. So we're just going to leave that till we multiply it by the 3. But we can do this 2 plus 3, and this 2 plus 3 is 5. So you get 3 times 2 times 5 squared minus 1. Now you might be tempted at this point to start multiplying, but remember, we got to take care of that exponent first. So we got to do 3 times 2, and then 5 squared is 25. All right, minus 1. Now you can just multiply left to right and simplify this part. I would do 2 times 25 first, 2 times 25, and you can do that. 2 times 25 is 50, and then 50 times 3 is 150. The reason I could do that is commutative property. And then 150 minus 1 is 149. All right, let's look at a couple other problems here. I think let's just do, let's pick one. Let's pick one that's a little possibly ugly. So let's do 53. Let's do this one right here. All right, so we got A over B, and that whole quantity squared. Well, 8 is A, B is 4. That whole quantity squared minus, all right, and then we have C is 16, and then we have A minus B, which is 8 minus 4. And if we have time, we'll do another one. So 8 over 4, we gotta do what's inside this parentheses first if we can. And we can, because this is a division problem. 8 divided by 4 is 2. So you get 2 squared minus, and then if you wanted to, because this 8 minus 4, remember when we talked about fractions, you can kind of treat what's in the denominator of a fraction as sort of being like its own thing. So 8 minus 4, we could do that. We can just call that 4. All right, and so we're doing all right. And then do 2 squared, which is 4, and then minus, and then we can also do this 16 divided by 4, because there's no other exponents left to do, especially on that. And the next operation on just this part right here is just doing the division. So 16 divided by 4 is 4. And hopefully you're seeing why it's really important to treat fractions like division problems and not just like there's something outside the laws of operations, because they're not. They're just division problems. 4 minus 4 is 0, and you're finished. So I think we have time to do one more. So let's do 54. I think 54 will be fun. All right, so we got 2 times A is 8 minus, and then B squared is 4 squared, and I'll just kind of let it hang like that this time. A times B, that's what AB means. AB means A times B. All right, so A times B would be 8 times 4. We'll write it like that. Plus, all right, C minus A is 16 minus 8 over B squared. B squared is 4 squared. So I think there's nothing to really simplify inside parentheses on these. We're using our parentheses largely or entirely as multiplication markers. So let's just go through and let's deal with our exponents next. So we got 2, and then I'll write this another way so it's not confusing. 2 times 8 minus 4 squared. Well, 4 squared is 16 over 8 times 4. I'm just rewriting these all as dot products. I can actually do this 16 minus 8 thing on the top here, and I'm going to. Let's do that. That's 8. All right, and then 4 squared is 16. All right, now let's finish doing the top. Well, 2 times 8 is 16, and you wind up with 16 minus 16, which, if you recognize some of these things early on, it can save yourself trouble. This is 0. And if this is 0, this whole thing is 0. And it just makes the whole thing go away. So you're left with this 8 over 16, and then you just simplify it to 1/2, and you're finished. So I hope this is helpful to you. I kind of have fun doing these problems. There's a lot of ways you can go wrong with them. And I just encourage you to just do as many as you can to just kind of get used to seeing different looks.